So this is the timing report they are showing, and here project summary. Now you see, now some timing you can see. See here timing, now something came. The previously no thing was there, the run implementation was there in the timing report. So now some words negative slack. Always remember that the slack should be positive. If slack is negative, then the constraints are not met. So see, two critical warnings are there, one warning is there, but no error.
No.
Whenever there is no error, it is okay, but critical warning sometimes may stop from mapping into the real mode. So you have to see some critical warnings. So implemented DRC report also you can see from here. So these are the 4 out of 4 logical ports, IO standard and default. These things you can read from here. They are telling how they have mapped and all the logical thing, everything, ground and voltage, about all the things they are telling. Which port is mapped and what are the informations regarding this.
Yes.
Now in implementation, now you have opened the implementation design. So now you can see the schematic of the open design. So here you again, this is the schematic after implementation, LUT2, and you see whether it is something changed or not, or it is the same thing. Achha. It is almost the same thing because it is the optimized design. And now the power timing, now again you see the report power after in implementation column. Run implementation, there is some report power. Now again report power, again this will be power. Suppose you give power 2 profile, because power 1 we have already created, first one. Now in this one you created this one. Now in this one you created okay. See, now you see the confidence level has come. The confidence level is low because the power is high. See, 0.66 watt is there. It should come in microwatt or milliwatt or like that, or nanowatt. So how to reduce this power? There is a technique called to generate the SAIF file. SAIF file. To how to generate? So you see when this report power you do, here in power supply environment, first one is the environment, in the next one in the power supply, and in switching here there is a option of giving you the SAIF file, .saif file. So here you click and it will not be automatically there, that file. So you have to give some command. So that command in the Google you search, what is two line or one line command. Same thing to generate the SAIF file. Now after generating that SAIF file, how to generate? Give the command. You will give the command in the TCL console. In this TCL console, here if you write a command, here in this box, if you write the command, whatever is given in the Google, that file in the same directory will be created. Then you again start the report power, and there in place of SAIF file, you give that file, okay, which is generated. So that file when you give and then again check power will be reduced. That file contains the switching activity of the simulation. That means the capacitance whenever it is charging and discharging, that within the entire simulation of the half wave, half adder, so how many times the capacitor is charging and how many times the capacitor is discharging, that record is there in the SAIF file. So whenever you give, the actual event will be placed in the entire circuit, not always all the signals are on at a time. Only at a particular time, a particular signal is on. So now this has considered all the signals are on at all time. That's why the power is high. But in half adder, sometimes the carry will be high, sometimes the sum will be high. So only those time the capacitor will be charged to 1 and then again discharged to 0.
Discharge to 0.
So that simulation time is stored in the SIFE file. So that if you give, you will give the actual power, correct power.
Okay.
So power reduction technique is a low power technique. One of the techniques. Second technique is there called gated clock. Gated clock or clock gating. Clock gating means suppose you are giving a gate through clock you are giving the flip-flop. Clock you are giving to flip-flop. Now directly the clock is fed to flip-flop. Without directly feeding the clock to flip-flop, you feed it through some gate. And then the output of the gate you feed it to the flip-flop. That is gated clock.
Gated clock.
That reduces the power. Okay. That is also known as clock gating technique.
Clock gating technique.
So these two technique I told you, SIFE file and clock gating technique. And in ASIC, there are another technique called VDD scaling.
VDD scaling.
Here you cannot handle because already the LV CMOS is taken model. So the input power and ground some value it will take by automatic. But in ASIC you can change that value. Okay. In ASIC you give that value as changing power scaling and then you can reduce the power, the VDD and ground. Now what you do is power is there and timing is there. Now another thing I forgot to tell you that power constant, a timing constant. Constant wizard is there. So you define the target. Oh sorry, in timing constant you have to do, not this constant. So here, not in synthesis also, in simulation, okay. In simulation, not simulation, open, here in synthesis, under synthesis there is constant wizard and edit timing constants. So in constant wizard loading device, now define target. Here in the Google you search for that device, that means RTX 7. What is the XDC file? .xdc. .xdc file. That is timing constant file. In that you can specify a command called create_clock. That means you are creating the clock with a particular period, clock period. Okay, that clock period, if you inverse, that will be the frequency. That means that megahertz frequency it will run by that speed. 1 by time period is frequency. So that frequency is the frequency operation of the circuit. Okay. So create_clock, you see the command, you try this using the clock constant, and then the actual all 00 timing was coming, NA was coming, there some value will come. Okay, sir. So you have to meet the slack as positive. There is some setup delay and there is some hold delay in the flip-flop. So that you have to adjust. Setup delay means the data is coming constantly, okay, to the flip-flop. At a particular, after some delay, the data becomes stable. Then only we can count the initialized state of the flip-flop. Okay. After the flip-flop, the output comes from the flip-flop output. After the flip-flop also some time is there, then the output becomes steady after some hold state. So that value you have to consider, the setup time delay and the hold time delay. And whatever constant you are giving in the clock, that is the entire setup plus the logic combo logic plus sequential logic plus the hold delay, then the output. So total, if you give the constant, suppose as 10 nanosecond, the 10 nanosecond consists of the setup delay as the flip-flop gate delay of the combinational, if there is some combinational logic, combo logic delay, plus the sequential flip-flop delay, plus the hold delay, and then you get the output. So that not much tough work is there. Only one create underscore clock, that one is there. Set input delay is another command. Set output delay is another command. 3 commands you need. That is create clock, set input delay, set output delay, and there is another set power optimization, set power opt for power optimization. So if you give this, then power and area means the number of lookup tables it is using. Area graph I am telling. I have told about power, I have told about timing. And third thing what you check is report in the project summary. This is the area. That means the lookup table. See this graph. Device utilization graph. See, only the input output is 1% in the table utilization, and the output utilizations, this is the LUT utilization, the lookup table utilization. This is the area actually. The graph post implementation. Post implementation means after here you implement the thing, after synthesis. The implementation, that is after implementation is this. Post synthesis means you have not implemented, only synthesis you have done. That will give this power. See this, it is same 1%, post implementation also 1%. So no need to worry. So same thing it has come. So this is the overview I have given. Now you can practice a lot of things are there. So you practice the thing.